Hey folks, how's it going? This is a little video that I decided to put together about piecewise. This one is called writing piecewise functions. So in this video, I'm going to give you a few different graphs of piecewise. I'm going to write some of them. In some cases, I'll give you a chance to try first. But in all of them, I'm going to write out the piecewise function and show you how do we do this. Now, there's going to be some things I'm going to break down as you're going to see, and you're going to see how I'm going to write it from step to step. I recommend that you definitely take a look at that resource that I handed out and that we spent time doing together in class, because I think that will help you see the steps, and they're going to basically be the same no matter what piecewise we do. So I'm going to start with this one right here. All right. Now, when I write a piecewise function, the first thing I need to show you is this. Whenever you get a piecewise function, if, generally speaking, they are not going to be connected in a situation where one is a closed dot, one is an open dot. If I connect them without any context, you're not going to know how to do the or equal signs. Which one's going to be less than or equal? Which one's going to be greater than? How would you do that? If that was the case, I would leave it up to your interpretation. There could be a couple different ways to do this. In this case, as you're going to see with the domains, there's only one way you can do the inequality. So I'm going to start by doing my f of x, and remember, we do our s and then our backwards s. It takes a lot of practice. I've been practicing this since like 5th grade, right? I've been doing squiggles since the 5th grade, okay? So basically, I'm going to do one piece at a time. I'm going to write the function. I'm going to write the domain. I'm going to go from left to right. So the first piece is this piece right here. So I'm going to say, look, this is, let's pretend this is a graph. Imagine if it goes on forever. What would this graph look like? Well, this would be a graph with a slope of 1. And if it kept going, it would have an intercept of 5. So the graph function rule is x plus 5. Where is this graph going? Well, look at the x's. It starts when x is -2, and it's all the values such that x is less than or equal. Remember the Sophia H rule. More ink to fill in the dot, more ink to write the or equal, okay? So that's the first piece. The second piece, this is a flat line. It's constant. It doesn't matter what x is. So what that means is, notice the y value of 5. 5. And that is when x is greater than -2. And that's all you do. So one piece at a time. You're going to write the rule, the domain, the rule, the domain. The domain is not based on y. Don't forget, I said this. This is the biggest mistake people do. They make it based on the y's. It's based on the x's. And remember, that's because x is the independent variable. X is what controls everything, right? Because these piecewise functions are like, look, if you plug in a number, what comes out depends on what is plugged in. It depends. If I have an x that's like -2, I'm going to use this rule. If I have an x that's 5, I'm going to use this rule. So it's based on what the output depends on, and that's the input, okay? So be really careful when you do that. So if you need a second to go back and take a look at this, I invite you to do that. Otherwise, I'm going to go ahead and move to the next one. Okay? On this next one, here's what I'm going to ask you to do. I'm going to ask you to pause the video. I'm going to ask you to try to do it. And then in a second, I'll go ahead and fill it in. All right, take a look at this one right here. So this one's got 3 pieces. So it doesn't matter if I don't tell you what to call the function. You can call it whatever you want. You could call it f of x, g of x, h of x. Try to use one of those letters. Don't use like L of x. It kind of looks like a 1. Try not to use like O of x. Looks like a 0. Okay, but I'll leave it. You know, I'll leave it up to you. Generally, your personal interpretation. So let's take a look at the first piece right here. Remember, we're going left to right. So the first piece, notice it's going up 1 over 2. Up 1 over 2. So that means it's going to have a slope of 2. And I put the x, the 2 next to the x, because that's where the slope goes. And then if I keep going, up 2 over 1, up 2 over 1, up 2 over 1. See how it's going like that? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, right? You got to be careful how many you go up. See, I actually went too high on that dot, right? Because it should be only 2. So you're going to end up at positive 8 on the y-axis. Where is it? This is 4. Is it an open dot or a closed dot? It's an open dot. So x is less than 4. All right, my next piece. Let's take a look. So here I go. Let's take a look at this one. Notice slope down 1 over 2, down 1 over 2, meaning slope of negative 1/2. I stick the x next to the 1/2 because that's where the slope goes. Notice it's touching the y-axis at 1, intercept of plus 1. Where does it start? So notice, sorry, this should be a negative 4. Notice how it picks up right where the last one left off. So it starts at negative 4, less than or equal because it's a closed dot, all the way up to 1. Keep it a not or equal because that is where it stops. Again, observe how I'm basing everything off of the x values, not the y values. Okay, last piece. Notice it's going up. Now, you got to be careful here. Up 4 over 1, up 4 over 1. So again, slope is 4. Stick the 4 next to the x because that's where the slope goes. Now, backtrack. So if I'm going up 4 over 1, okay, I'm going down 4 and left 1. So 1, 2, 3, 4 over 1, meaning I'd be at minus 8. Okay, and that's going to go from 1 is less than or equal to x is less than nothing because it goes on forever. Okay, so again, wherever you see a ray, you're only going to have one inequality because x is not going to be constrained. It's not going to be stopped in one of the two directions. So for example, here it's just x is less than negative 4. There's nothing that says what x can't be less than, but it's got to stop at negative 4. So the fact that there's only one number in the inequality versus these two, and there's only one inequality sign, tells me it's going to stop somewhere, but only on one end. Okay, if you see a start and a stop, your inequality has to be a compound and inequality that indicates where it starts and where it stops, okay? X is going to be more than or equal to negative 4, and it's going to be less than 1. More than or equal to negative 4 and less than 1. Okay, so all we're doing is we're writing the slope and the intercept, more or less we're writing the equations one piece at a time, and then writing the inequalities one at a time. Again, note making sure that that's a negative 4 because that's the pickup point. And also notice if we use that thing that I called the May method here, boop, 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 and I start to draw these tick marks, notice how the tick marks at negative 4 and 1 line up with the cutoff points that I use in my formula. So if you need a second to go back and take a look at that, go ahead. And then in a moment, I'm going to move on to the next problem. All right, I'm going to do, so the next two are going to be ones with 4 pieces. I'm going to do one, and then I'm going to have you try, and then I'll recap one, okay? All right, so let's take a look at this piece right here. Now, I've got 4 pieces here. So what that means is I'm going to expect to see 4 inequalities and 4 rules, okay? Before we start, one good thing to think about is what kinds of inequalities should I expect to see? So I'm going to expect a simple inequality here with only one inequality in it. And I know that's because it's going to have to stop when x is equal to negative 4, but it's not going to stop on the other end. Here I'm going to have a compound and inequality because I see a segment. Another compound inequality, it's an and then one simple inequality because this one only stops at one end. All right, so let's try to write my rules here. First one is this is going to be constant. So I'm going to write the constant. Notice it's a constant at 5. And I'm going to have that when x is less than -4 because it stops at -4 on the x, but it's an open circle. The next one's going to be kind of tough. So take a look. It's going down 1 over 3. So I know my slope is -1/3, and I drop the x there. But how do I find the b value? That's not easy. So down here, you don't write it up here. Down here, let's do a little work. This was a strategy a student in class really astutely suggested. Well, notice that I have this formula, right? I have y equals -1/3 x plus b, okay? Now, what I know is that if y is equal to 3, okay, well, then x is equal to -1, okay? And here's why I know that. Let me get it in there for a second, okay? Notice that this is a point right here, okay? This is the point -1, 3. And that means the x is -1 and the y is 3. But remember, a point is on the graph of a line only when you plug in the x and the y and it makes the equation true. So because -1, 3 is on this line, when I plug in -1 for x and 3 for y, both sides have to be equal. So 3 is equal to 1/3 plus b. So what's b? Well, b is 2 and 2/3. That's one way to look at it. Or, okay, you could convert this and call it 8/3. I'm going to stick with the mixed number. Okay, so I come back up here, and I'm going to write plus 2 and 2/3. So sometimes you do have to do that, and you know what? That's okay. So I'm going to have that one when -4 is less than or equal to x, which is less than or equal to -1. Okay? Notice it goes from -4 to -1 on the x. All right, next piece. Here we go. So I've got a slope of down 2 over 1, down 2 over 1, down 2 over 1. That's a slope of -2. Stick that next to the x because that's where the slope goes. Observe the intercept is -1. Okay? And this one's going to go from -1 is less than x is less than or equal to, where does it stop, folks? Is it going to be -5 or is it going to be 2? It is going to be 2 because that's the x value at that trade-off point, okay? 2. Finally, let's look at my last piece. This was a tricky one. So notice, this one's going up 1, over 1, up 1, 2, 3, 4, 5, 6, 7. So I'd have to go down. So that means a slope of 7. So I'll write 7 with my x next to it. And now let's see what happens. 1, 2, 3, 4, 5, 6, 7. Darn, where would I go? Well, let's think about it. If I'm at 1 and I'm at -5, if I go down another 7 and over 1, that's how I'm going to hit the y-axis. So where am I going to be at if I go down another 7 from -5? Excuse me. Where I'm going to be is at -12. Because think about it. If I go to, I'm at 5, -6, -7, -8, -9, -10, -11, -12, and over 1. Okay, and I'm going to do that when x is more than -2. Be careful how you do your signs. So I'm going to rewrite it like this. I'm going to write x is more than 2. Not -2, but +2. Okay? So again, when you're doing this, you're doing it like this. You're going piece by piece. You're writing the rule for the piece and the inequality. So it's 5 when x is less than -4. It's -1/3 x plus 2 and 2/3. And remember, we did that because we used the rule of plugging it in. Okay? and solving for b. Sometimes you have to do that. And that's from negative 4 is less than or equal to x is less than or equal to negative 1. Then we have the rule negative 2x minus 1. And this one was good because this one was where it crossed the y-axis. And generally, for any function, 0 is going to be an input. So what that means is one of the points is going to have a y-intercept, or rather one of the lines. So we have our down 2 over 1 and our intercept of negative 1, 0. And that goes from negative 1 to 2. And lastly, we used intuited here from backtracking back to the y-intercept. Now, you could have also plugged in, you could have said when x is 2, y is 1 in theory, even though it's not really a point on the line. You could have solved, you could have said, okay, 7 times 2 is 14. Well, b has to be negative 12 to get back to the point. So there's a lot of different ways you could do this, but what you want to do is, and wait a minute, this is a time where Mr. Murray made a mistake. Let's see if we did this right. So let's see, just check this again. 1, 2, 3, 4, 5, 6. Uh-oh. I went over by 6. So it shouldn't be negative 12. It should be negative 13. Okay? So that's why you always want to make sure you watch out the whole example. What happened here? So look, I'm going up 7 over 1. So you have to go 1, 2, 3, 4, 5, 6, 7. I only went down 6. Okay? So anyway, but the idea is for each point, for each piece, you're going to write the rule, and then you're going to write the inequality where that rule applies, okay? So I've got 5, and this one's a tough one. I may not do one this difficult, maybe more in like a, not like a typical question, but a possible question you might encounter. All right, so if need be, go ahead and take a look back through this, and then when you're ready, I'm going to move on to the next one. All right, folks, last one is what I got right here on the right. Here's what I'm going to ask you to do. This is a quick 4-piecer. I'm going to ask you to try it. So I'm going to ask you to pause the video, and then when you're ready, unpause it, and I'll show you how to do it. All right, here we go. Hopefully you got yourself a good answer to this one, and it's not an easy one, okay? So again, you drop in your f of x, squiggle. So remember, I've got 4 pieces here. I'm going to go left to right. So the first piece, let's take a look. I'm going down 1, 2, 3 over 1, down 1, 2, 3 over 1. It's a slope of negative 3x. Or it's a slope of negative 3, but I'm putting it next to the x. Then I go 1, 2, 3 over, 1, 2, 3 over, 1, 2, 3 over, 1, 2, 3 over. So I'd get to negative 9. Let's make sure that's right. If I plug in 4, I should get negative 4. I should get 3. Okay? Let's see what happens. Negative 3 times negative 4 is 12. Minus 9 is 3. Where did I get that from? Notice, negative 4, 3 is this point right here. Again, if it's on the line, when I plug in negative 4 for x, what I should get is 3, because 3 is the y. So negative 3 times negative 4, again, that's 12. Minus 9 is 3. So I'm going to do that to make sure it works. And that's from when x is less than or equal to negative 4. If you can't tell, I'm kind of a big fan of negative 4. Okay? All right, let's look at our second piece. So here, it looks like we've got a slope of up 1 over 3. So I put my third, I drop my x next to the third because that's the slope. And I'm going up 3 over 1. Uh-oh, what's going to happen? Well, let's take another look. So I'm going to have my y equals 1/3 x plus b. Okay, and I'm going to hone in on the point negative 1, 1. So if y is equal to 1, x is equal to negative 1, right? Negative 1, 1. So what I have is 1 equals negative 1/3 plus b. So adding b to both sides, you get b equals 1 and 1/3, or 4/3. I'm going to do 1 and 1/3. I'm okay personally with that. Okay, and that goes from when x is more than negative 4 to when x is equal to or less than negative 1. Not 1. Okay, that's where people get mixed up. See, I almost got hit by that? -1, okay? All right, next piece. Notice I'm going down 2 over 1, down 2 over 1, meaning my slope is -2. I drop the x next to -2 because that's where the slope goes. I can see clearly now my intercept's -3. All right, that's my attempt to do a little song in that one. Okay, maybe you understand that reference even. Okay, and I'm going from -1 is less than x is less than or equal to +1. Okay, because that's where it starts and where it ends. Remember the Sophia H rule: more ink to fill in the dot, more ink to write the or equal. Last piece, this one. So notice I'm going up 3 over 1, so I drop my 3x. And let's see if we can make sense of this. Well, I'm at -7 now. If I go down 3, I get to -10. Over 1, I hit the intercept. Let's test it. If I plug in 1, I should get -7. 1 times 3 is 3, minus 10 is -7, so I'm good to go. And this one goes from when x is more than 1, right on to infinity, okay? So just like with every piecewise, you're gonna write the rule for one piece at a time, right? Here's piece 1, here's piece 2, here's piece 3, here's piece 4, okay? And then you're going to write the rule for one piece at a time. And after you've written the rule one piece at a time, what you're going to do is then you're just going to put them together all in one rule. Okay? 1, 2, 3, 4. All right, so I hope you enjoyed this video. I hope you found this video to be informational. Again, please continue to send me questions. I love when you guys do that. But remember, you can do it, okay? So thank you very much for watching this. Thanks for sticking through my technical difficulties. And I hope that you learned through this that, look, we all make mistakes. No one does this perfectly. I've made mistakes in this video, okay? But that's all right. That's how we learn. So keep working through it. Keep enjoying math, and I'll see you next time.